Hello everyone, this is Hannah B. Gambal, taking course of Bachelor of Science Information System from St. Francis College, Kiholgan City. And now, I will discuss about mathematics in the modern world. Mathematics in the modern world. Math 1. Module 5. Mathematical system. A mathematical system consists of a set of elements and one or more binary operation to connect these elements. A mathematical system consists of a set of elements and at least one binary operation. A binary operation is an operation or rule that can be performed on two and only two elements of a set with the result being a single element. In mathematics, a binary operation or dyadic operation is a calculation that combines two elements which called of operands to produce another element. More formally, a binary operation is an operation of variety 2. Examples includes the familiar arithmetic operations of addition, subtraction, and multiplication. Unary operation. A unary operation is an operation on single element. Example, number 1, squaring 4. The square of 4 is written as 4 squared, which gives 16 as the answer. In this case, 16 is the square of number. Number 2, finding the square root of 9. The square root of 9 is 3. That is the positive solution of the equation is times 2 equals 9. The number 9 is a perfect square. The square root of 9 is 3. Therefore, 9 divided by 9 equals 9 times 3 equals 27. The symbols. A binary operation is an operation that combines two elements of a set to give a single element. Example, number 1, multiplication. 3 times 4 equals 12. Number 2, matrix subtraction. 5, 3 minus 4, 1 equals 1 and 2. Evaluate the determinants. 1, 3 minus 1 minus 2. Second, 3 minus 4 minus 5. The third, 0, 1 minus 2, 4 minus 1, and 2. Consider a binary operation on the set 1, 2, 3, 4, 5 given by the following multiplication table. Compute 2 times 3 times 4 equals 5. Properties of systems. Suppose a system consists of a set S and a binary operation. The system can the following properties. Property closure. The description. Set S is closed if all of the elements of set S combine to give an answer also in set S. Examples, A times B equals C, where A, B, C equals S. Identify element. An identify element leaves every element of the set S unchanged. Examples, A times I equals A. I times A equals A, where I is the identify element. Inverse element. An element and its inverse combine to give the identify element. Examples, A times B equals I. B times A equals I, where A and B are inverses. Commutative property. An operation is commutative if the order in which of the elements are combined does not change the result. Example, A times B equals B times A. Associative property. An operation is associative if when combining the elements, the grouping of the elements does not change the result. Example, A times B times C equals AB times C. Distributive property. Given two operation and then is distributive over as in the example. Examples, A times B and C equals A times B and A times C. Example 1. Give examples to show the following properties for the system I and plus. A. Closure. 5 plus negative 2 equals 3 and 3 equals I. B. the element. 3 plus 0 equals 3. 0 is the identified element. Inverse. 3 plus negative 3 equals 0. 3 and negative 3 are inverses. Letter D, commutativity. 3 plus negative 2 and equals negative 2 plus 3. Associativity. 3 plus 4 plus 5 equals 3 plus 4 plus 5. Example number 2. Give examples of systems that are not A. Commutative, I and negative, E and G, and 3 negative 4 is not equal to 4 negative 3. Number 2, letter B, closed, W and divide, E and G, and 3 divided by 4 equals 0.5 and 0.75 equals W. Groups are mathematical systems that possess certain properties. A mathematical system is S and times is a group of it possesses the following properties. Letter A, set S is closed under the operation. Set B, there is an identified element in set S. Letter C, every element has an inverse in set S. Letter D, the associative property applies to the system. Tables. Many systems can be shown in tables for the system A, B, C, and multiplication. First, times A, B, C. Second, A, B, C, B, B, C, A, C, C, A, B. For a system to be a group, every element must occur only once in each row and column of the table. The group properties can easily be tested from these tables. A. Closure. Every element in the table is the set A, B, C. Letter B. Identify element. Look for a column that is in the same order as the original set I, E, and A is the identity element. C. Inverses. Look for the identity element in each row. A times A equals A. B times C equals A. C times B equals A. This shows that each element has inverse. D. Associative property. It is difficult to show that every combination of elements is associative. Check an example. Example, A times B times C equals A times B times C. Therefore, B times C equals A times A. And A equals A. Conclusion, A, B, C, and times is a group. As the group also shows commutativity, it is called an abelian or commutative group. Modular arithmetic. This is a type of number system where numbers are represented by the remainder after division by the modulo number. E and G. In Module 6, the number 8 is given as 2. The remainder when 8 is divided by 6.